Hello. Good evening, my dear students. Very good evening to all of you. How are you? Okay. So we are here. How many students are there? Five waiting students. Trick for cationic discharge series. Late Professor BCS. Beta Z. It is not G. Ananya. That's not Z. That is not G. It is Z. Had cup made up of silver plated gold. Yep. The spelling you have made it mesental. TL. Now tell it today itself again. Ananya. Welcome to the session of electrochemistry where we are going to talk about the electrolysis. We have talked about the electrochemical series. We have talked about the electrochemical cells, but we have not done many of the questions of electrochemical cells. So today we are going to begin over with a few questions of electrochemical cells just to have a warm up so that you will be able to attempt all the questions today. Today at 8 o'clock we are going to have the sessions in which we are going to do all the questions of electrochemistry. So I believe I have got all my five students with me. Yep, all five students are here. That's great to see. And I have shared with you something else also on the group. You can join that particular website so that you can get all the questions. So many questions to practice. Okay, so let's begin over with electrochemistry and electrolysis. Starting, we are going to do some questions. Electrolysis is not a very big topic, so I believe we'll be able to finish off electrolysis and finish off the NCRT reading as well today. Okay, and I have seen you are quite serious. So many of the students have already made the notes and put it on the group. Now we are going to even have it on the website so that you will be able to do it much better. Clear? Good afternoon, good evening, Ujla Mustafa. Welcome, Ujla Mustafa. You were not there in the yesterday's class. Today you are here. Fine. Okay, to begin over with this class, here we are. So that's me. My name is Anoop Vashishtha. I'm an MSc in chemistry from University of Delhi. 26 years teaching experience. Lakhs of students have been taught. Blah, blah, blah. That's enough. So let's begin over with the questions. Where are the questions? Here are the questions. Okay. Question number one. Find E cell of. In the yesterday's class, we have done cell representation. If you have done the notes, then in that case, you would be knowing what the cell representation is and how we can use it. Now, cell is this Zn solid, Zn2 plus aqueous. The concentration is 0.1 molar. Here we have Cu 2 plus, and that's aqueous. The concentration is 0.001 molar. And here we have Cu solid. Temperature is 298 Kelvin. E naught Zn2 plus 2 Zn is equal to minus 0.76 volt. E naught Cu2 plus 2 Cu is equal to plus 0.34 volt. So you have to give me E cell. Now E cell is E naught cell minus 0.0591 by N log Q at 298 Kelvin. Give me the answer what exactly it is. It is not a multiple choice question. It's a theoretical question. You have to give me the answer on the chart. Quickly give me the answer. Good afternoon, Pranshu. Good afternoon, everybody. Ujla, I believe you are going to enjoy this particular class. And if you have not attended last class, then in that case, I'll sincerely ask you to attend yesterday's class. Yesterday, we had 5.5 hours of electrochemistry class. It was a marathon session, but we finished electrochemistry in record time. Electrochemistry is the longest chapter in chemistry. Okay, so what's the answer here? The formula is written in front of you. So go ahead and join it. You do it. And when we talk about something like E naught cell, that is E naught cathode. Cathode is the positive terminal, whichever it has the positive value of the reduction potential, minus E naught anode. The anode is the one which has more negative value. Or you can say right minus left. Okay, answer. Piyush, no, the answer is not 1.1 Piyush. E naught value is 1.1. E naught value is 1.1 when we talk about E cell value. E cell value will be turning out to be different. See, E naught cell here comes out to be E naught cell will be equal to plus 0.34 volt minus 0.76 volt. And that comes out to be plus 1.1 volt. Clear? That is E naught cell. Now, E cell will be equal to 1.1 minus 0.0591 divided by N. N in this case is 2. Log Q. Q is the product upon the reactant. Now, on the left hand side, this is the product. On the right hand side, this is the reactant. Clear? So here what we get is that the product is concentration of Zn2 plus divided by concentration of Cu2 plus. Now that value somehow this turns out to be 1.1 minus 0.0591 by 2 log 0.001 zero point 0.1 upon 0.001. Clear? So that actually becomes 1.1 minus 0.0591 by 2 log 100. And log 100 is 2. So it comes out to be 1.1 minus 0.0591 by 2 into 2. And that's equal to 1.1 minus 0.0591 is equal to 1.0409 volts. Maybe some people can round it off and say 1.041 volts. That's okay. Ananya, we have not yet done electrolysis. Overpotential is going to be in electrolysis. So wait for it. Any confusions here? All people who are in the class, have they already liked the class? Go ahead and like the class. So that was the question. Clear? Okay, let's have the second question. The next question is here we have zinc as 0.001 molar and copper as 0.1 molar. Okay. E naught Cu2 plus 2 Cu is equal to plus 0.34 volt. E naught Zn2 plus 2 Zn is equal to minus 0.76 volt. So that is the question. Give me the answer. What will be the E cell in this case? अनन्या, किस बेसिस पर डिसाइड किया जाता है कि कहां ऑक्सीडेशन होगा कहां रिडक्शन? द वन विच हैज द मैक्सिमम नेगेटिव पोटेंशियल, reduction potential, that is going to undergo oxidation, and the one which has the most positive reduction potential, that is going to undergo reduction. Clear? More positive is the potential, more favorable is the reaction, and we are talking about reduction potential. So the one which has the most positive reduction potential will undergo reduction. Clear? And the left hand side is the oxidation electrode. So whatever is written on the left hand side, there oxidation takes place. Ananya, you were there in the yesterday's class. So what happened? Did you not write the notes? Thanks, Ujala Mustafa. Jite raho. So Ananya, you did not make the notes. You have to make the notes, isn't it? And that is necessary for revision. Yep, Tirthraj, we have got the answer. It is 1.1591. 1.1591 volt. That is the answer. I hope you are going to get it. Now, the answer is very simple. Like, more is concentration of reactant, higher is E cell. Clear? And similarly, more is concentration of product, lower is E cell. So by changing the concentration of reactant and product, we can actually change the E cell. Fine? Okay, so any confusions here? Ujla Mustafa, please somebody give him the information of our WhatsApp group. And yes, class is always on this time only, Ujla. It's 4 p.m. and we have the special class at 8 p.m. Okay? Join us in the special class. Okay? You can give my phone number to him. More is the concentration of product, lower is the E cell. So this is what we have as a question. Now, let's have a very special question. I like this question a lot. Question is, for a zinc copper cell, if the concentration of Zn2 plus is 1 molar, calculate the concentration of Cu2 plus so that the cell is at equilibrium. Okay, you need to give me the concentration of Cu2 plus so that the cell is at equilibrium. Okay, our plus courses are going to start from 1st of August and the timing would be 7:30 p.m. Okay, Those who want to join the plus courses, they can join it. Answer. Great, Ujla. So give me the answer. Now, you need to understand at equilibrium, E cell is equal to 0. So the equation is going to be E0 is equal to E naught cell minus 0.0591 by N log Q. So this is going to be 0 is equal to 1.1 minus 0.0591 by 2 log concentration of Zn2 plus divided by concentration of Cu2 plus. So that is going to be 0 is equal to 1.1 minus 0.0591 by 2 log. The Zn2 plus concentration is already being given to you as 1 divided by concentration of Cu2 plus. Now you have to give me the concentration of Cu2 plus. So you just have to twist and turn the log values. What's the answer? Answer. You need 2 minutes for this question. I have already written the answer in front of you. Just go ahead and twist and turn it. It's going to be 2 point, so it's going to be log 1 by Cu2 plus is going to be equal to 1.1 into 2 divided by 0.0591. You can take it at 0.6. So do you know what? Concentration of Cu2 plus will actually turn out to be 10 raised to power minus 37.2. Is that clear? Correct? Great. Now let's have another question. Give me the E cell of this. Medical wale. Sir, organic कब start चलोगी? Beta, let us finish our physical first. Then we are going to start it. Okay? We are going to do everything one by one. Start it. Do this question. We have to do a lot of things. Be a little fast. If you have done the revision, you should be a bit faster. Answer. Mark it, Peter. The answer is going to be, now remember, here the E cell is equal to E naught cell minus 0.0591 by n log Q. Now here the E naught cell actually is 0. Can you see that? Priyanshu, think over it once again. This is the product. This is the reactant. On the left-hand side, the oxidized species is the product. On the right-hand side, the reduced species is the product. That's what we have discussed yesterday. Isn't it, Priyanshu? Medical Wale, did you attend yesterday's class? If you have not attended yesterday's class, I'll sincerely and forcefully say that you have to see all the classes yesterday. You cannot just barge in any class and say, समझ नहीं आता या हमसे होता नहीं है. You have to see the class. Okay? And if still you are not able to do, we are doing the questions right now. Solve it. And please remember, this is a very small batch. Very, very small batch. With all standards, it's a very small batch. I have no problems in making it still smaller. Clear? Tirthraj, the answer is not negative, it's positive. How do we get it positive? So E cell is equal to minus 0.0591 by 2 log. Now the product is 0.001 and the reactant is 0.1. Clear? So this actually turns out to be minus 0.0591 by 2 log 1 by 100. So log of 1 by 100 is actually equal to minus 2. So the answer is plus 0.0591. Don't make this kind of a silly mistake. You are not allowed to make this kind of a silly mistake. Clear? The answer is mine is plus 0.0591. Now, as you can very well see, the E naught cell is actually 0. but the cell still works. The cell still works because of the difference in the concentration. Now here we have the term called concentration cells. The cells which work due to difference in concentration or partial pressures. E naught cell for the concentration cell is 0 because we have the same cathode and the same anode. Any kind of confusions here? So the example that we have just done was a concentration cell. Fine. Okay. Now we are going to do a bit of questions about hydrogen electrode. Okay, let's have the next page. The pages are not costing anything because we are not using actual pages. So let's talk about hydrogen electrode. Okay. Hydrogen electrode is something like we have a reaction could be H plus plus electron giving us 1 by 2 H2. Okay. Now just you to need to remember that E naught H plus H2 is equal to 0. So the hydrogen electrode, the potential is 0. For this reaction, if we talk about EH plus H2, it's going to be E naught H plus H2 minus 0.0591. And remember, here is only one electron, so it is going to be 1 log partial pressure of hydrogen being the product raised to power 1 by 2 divided by the concentration of H plus. Is that clear? So this is going to be the equation for this. This is going to be the Nernst equation for this particular reaction. Clear? But if I write the equation as 2H plus 2 electrons gives us H2. Now EH plus upon H2. Now remember this one part is 0. So that actually translates to EH plus by H2 is equal to minus 0.0591 log partial pressure of hydrogen raised to power 1 by 2 divided by the concentration of H plus. Is this clear? This equation is clear to you? And then here the equation is going to become as minus 0.0591 by 2. Okay. Log partial pressure of hydrogen divided by the concentration of H plus raised to power 2. Both the equations are absolutely correct. You need to understand that N and Q balance each other. They counteract each other. So by changing the balancing of the equation, you actually do not change the E values. Till the time you take the Q and N from the same equation. Anyone has to ask anything here? Okay, remember this equation. Now we are going to do the question. Okay, the representation of hydrogen electrode. See, hydrogen electrode is a gas electrode, and being a gas electrode, we cannot make the electrode per se of hydrogen. So hydrogen electrode is sometimes represented as H plus, aqueous. Okay, then it is H2, gaseous, and then it is an electrode. Most often that electrode is platinum. So that is what we have as a representation of the hydrogen electrode when we are talking about the hydrogen electrode being reduced, acting as a cathode. If it is acting as an anode, it's going to be reversed, PtH2H plus. Okay, fine. So let's get the question. Question. Calculate the potential of hydrogen electrode under 1 bar H2 at 298 Kelvin, and the first one, dipped in 0.1 molar HCl. Second, dipped in a solution of pH 4. Third, dipped in pure water. Fourth, dipped in 0.1 molar NaOH. So, give me the answer. These are 4 questions, and these questions, all 4 questions can be done together under 1 minute. Answer. Answer. EH plus H2 is equal to minus 0.0591 log partial pressure of hydrogen raised to power 1 by 2 divided by the concentration of H plus. So the first one would be EH plus H2 is equal to minus 0.0591 log 1 divided by the concentration of H plus is 10 raised to power minus 1. That is 0.1 molar. So, what's the answer did you get? अनन्या, फर्स्ट एंड सेकंड हैव यू डन इट? थर्ड वाला कैसे होगा? थर्ड वाला बहुत आसानी से होगा. Ananya, you have not given me the answer of first and second. Why are you jumping on to the third? Give me the answer first and second first. First one is not 0.0591. First one is 0.591. Oh, yeah, no, no, it is 0.0591. Fine enough. Okay, first one is minus 0.0591. What is the second one? Ratnadeep Kore, beta, don't miss the sign. If you miss the sign, you are going to miss the marks. Actually, EH plus H2 can be simply written as minus 0.0591 pH. Because what is pH? pH is equal to log of 1 by concentration of H plus. So the second one would be even easier. And dipped in pure water. Ananya, you have forgotten. The pure water pH is 7 at 298 Kelvin. So the question is gone. Here, the pH will be equal to 13. So is there any difficulty in the question? Is the question absolutely clear? Whoever has not liked the session as yet, go ahead and like it. Clear? Okay. So that's what we had, the questions. And now we are going to talk about electro electrolysis. Okay. Electrolysis is reverse of electrochemical cell. Here we are using electrical energy to convert it into the chemical energy. Ratndeep Kore, I believe today, have you joined the WhatsApp group? If you have not joined the WhatsApp group, go ahead and join the WhatsApp group. And if you have joined the WhatsApp group, I have given you a website. Join that website, and you are going to get thousands of PYQs. Thousands. Okay, clear? And Ratndeep, today we have 8 p.m. class. Are you gonna join it? 8 p.m. special class. There we are going to do the questions. Let's talk about electrolysis. Electrolysis would mean that the chemical species, the ions, they accept the charge from the electricity and convert. The reaction are taking place with the consumption of electricity. That is electrolysis. सेकेंड क्वेश्चन का करेक्ट आंसर क्या है? इट इज गोइंग टू बी -0.0591 into 4. Clear? Okay. Now remember, in electrolysis, the first point, the negative terminal has excess of electrons, provided by the DC source. Now that DC source could be battery, could be an electrical generator, whatever it might be, but this is a DC source. Electrolysis requires a DC source. Conduction measurement requires AC source. Okay. So reduction takes place and it is the cathode. Okay. Second, the positive terminal has lack of electrons. So it removes the electron and causes oxidation. Okay. So anode is the positive terminal. Anybody has a problem here? Reverse of electrolysis is electrochemical cell. That's what we were doing till now. Any confusions here? Fine. Third point is negative ions, which we call as anions, move towards anode and are oxidized. It is not about what is getting easy, what is easy to, whether it is easy to oxidize or whether it is easy to reduce. The anions always get oxidized. It is not the other way around. Cations cannot be oxidized by electrolysis. Ananya, electrolytes undergo electrolysis. If there is no charge separation, the ions are not going to move. The species are not going to move under electrical influence. Electrical influence only works on charges, not on a neutral species. Fine. And so fourth, positive ions. Now that is called cations. Move towards cathode and are reduced. Have you noted it down? Any kind of asking question anybody has? Noted? Now, so we have two kind of discharge series, or there are two discharge series. One is what we have as cathodic. That means on cathode. That means cation. That means reduction. Okay. So there is one cathodic discharge series where the cations are discharged. And second one is anodic discharge series. That will be on anode. That is going to be anion, and that will be oxidation. Cathode, the cation moves towards the cathode. It is on cathode cation. Cation undergoes change on cathode. Cathode is the place, cation is the species which goes to that place. Got it, Piyush? We are going to do, Ananya, the questions we are going to do. But first of all, you need to understand the theory and be patient. Don't jump. Clear? It is much better to spend an hour now rather than spending an year afterwards. So to save your year, you will have to spend the hour. And I believe that's a quite a nice bargain. By spending 1 hour more, you can save 1 year. Clear? So that is what we have as cathodic discharge series and the anodic discharge series. These are two different series. And obviously, this cathodic discharge series is based on reduction potential. And the anodic discharge series should be based on oxidation potential or reverse of reduction potential. Is this clear? So now let's talk about the cathodic discharge series. Quite obviously, we have the electrochemical series. That electrochemical series gives us all the answers. No problems with that. But there is an easier way to learn the cathodic discharge series. So let's talk about, first of all, the cathodic discharge series. Now let's understand a simple and a few examples. Few examples. And when I do this few examples, I always give this. Ananya was giving us the example, was giving us a mnemonic. Made a little mistake, but still, she gave a mnemonic, isn't it? Fine, clear? And that is late Professor BCSMAZINTL had cup made of silver plated gold. Late Professor BCS Mezental had cup made of silver plated gold. That is late Professor BCS MEZINTL had cup made of silver plated gold. It's not an exhaustive series, but most often this series works and helps us to find the answers. Fine. Now, the position of species in this series depends on many factors. Fine. Okay. Now, the first thing which many of the students ask is over potential. The over potential. Now, what is the meaning of the over potential and how we are going to use this over potential? Over potential. Now, this is an extra potential required to release gases from covalent compounds. And the example is water. Okay. So when we talk about the release of hydrogen from water requires 0.8 volts. Instead of the 0 volt, this is expected. Is it clear? So that is why what we find is that here it is hydrogen, and this hydrogen is 0.1 molar at 298 kelvins. But if we talk about water, the hydrogen is actually going to shift here. And that is why the metals as reactive as zinc can be electrolyzed in aqueous medium. Thank you, Alpan Mishra, but don't spam. Okay. So the species as reactive as zinc can be extracted from water. Alapan Mishra, beta, in this class, these questions are not allowed. Okay. Fine. Now, so that is what we have as over potential. The same is with oxygen. And second one, second case is what we see is the concentration. The species with higher concentration has a higher chance of being extracted. So if we decrease the concentration, we can actually change the position of the species in this series. Clear? So higher concentration easily. Okay? Higher concentration is easily extracted. Ananya didn't have to answer. Don't. Don't let yourself be distracted. If anything is distracting you, simply block it. Don't answer. Okay? Third, the electrode. Now, this series is for platinum electrode. Okay. If we were using mercury electrode, hydrogen will be way up. On mercury electrode, it is easier to extract sodium than hydrogen. So what electrode we are using, it also changes the position of the species in this electrochemical series. Clear? Any confusions? Fine. Now, this is a series that you have to learn. Okay? And one thing you need to understand, species on the left of Zn will not be discharged in aqueous medium. Note it down. Just note it down. Note it down. Okay. I'll ask you a question. Simple question. Very, very simple question. Question is a solution, or as I should say, an aqueous solution has equimolar Ag plus, Mg2 plus, Cu2 plus, and Hg2 plus. An aqueous solution has equimolar Ag plus, Mg2 plus, Cu2 plus, and Hg2 plus. On electrolysis, give the order, which is first to last. Give the order of discharge of metal. Now, which of these metals will be discharged the first on cathode? So you have to give me the cathodic order. So from left to right of the series, the ability to discharge increases or decreases. It becomes more difficult on moving from right to left. The right ones are the easiest to discharge and left ones are the most difficult to discharge. Did you not see this particular statement? I said species on the left of zinc will not be discharged. So the left species are difficult to discharge. Okay. And we very well know that lithium has the most negative reduction potential. So it will be the most difficult to reduce. Clear? Ananya, Priyanshu, have you got the answer? Alapan Mishra, forget about decreases or increases. Don't say a single word. It's going to confuse. I have written the answer. So give me the answer to this particular question. Answer. Priyanshu, it's clear, but where is the answer? What do you think? This is some normal lecture going on. Some motivational lecture. This is not some motivational lecture. This is hardcore studies and you have to answer the questions. Ananya, MG would be the easiest or most difficult? Prerna, where did we get Na? Where did we get Na? It is Ag plus Mg2 plus Cu2 plus and Hg2 plus. These are the four species that we are talking about. So it is Mg, Cu, Hg and Ag. That is Ag would be the most easy and Mg would be the most difficult. That's what you are getting, Ananya. Give me the answer. Priyanshu has tried to give the answer. Ag plus Hg2 plus Cu2 plus Mg2 plus Mg, Cu, Hg, Ag. Okay, fine. The order is reversed of Ananya and Priyanshu, but they have the same order. What about others? What about others? And I'm just telling you, Ananya, Priyanshu both have a wrong answer. Even Tirthraj has a wrong answer. You don't listen. I have a dedicated team, but still you don't listen. You don't listen. I asked you to write this question, this statement. Do you know the meaning of this statement? I had asked you to write this particular statement. Tirthraj, Ananya, Priyanshu, do you know the meaning of this statement? With me, you cannot take chances. Mg2 plus will not be discharged. The order is going to be initially the first thing is going to be Ag plus, converting to Ag. Then it would be Hg2 plus, converting to Hg. And then it will be Cu2 plus, converting to Cu, and that's it. Then H2 will be released. Can you understand this? Can you understand this? You are realizing the importance of making notes. सब कुछ लुटा के होश में आए तो क्या किया. Please don't make it too late. Do it now. When I'm telling you something that you have to do it, I'm telling you from 26 years of experience. And still you are talking about, अब realize किया. Okay, so that's what we have as aqueous solution. This is what we have as the order of the discharge. Now let's talk about the very peculiar type of thing. That is the types of electrode. No, 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 no. We have just talked about the species. We have just talked about the cationic discharge series. Now let's talk about the anionic or anodic discharge series. Clear? When we talk about anodic discharge series, we are basically talking about whether the species from water would be released before oxygen or after oxygen. So what we find is F minus to F2, SO4 2 minus, NO3 minus, PO4 3 minus. They are not released from aqueous dilute solutions. They are not released from aqueous dilute solutions. Clear? Then we have H2O giving us O2, and then we have Cl minus to Cl2. We have Br minus to Br2. We have I minus to I2, and these are released. O2 as such should be released before chlorine, but O2 is not released. O2 is not released before Cl2 due to over potential. Clear? The O2 is not released before Cl2 due to over potential. Otherwise, as far as the potentials go, oxygen should be released before chlorine. Is this clear? Clear? Okay. Now we talk about the products of electrolysis. Now, this is a very important question that is generally asked, and this question is also in NCERT. This question is for 11th class also, and this question is a very important one. Products of electrolysis. Now, we have certain common thing, that is aqueous medium, platinum electrode, 298 Kelvin. So these are the common things which we are going to do in these questions. Aqueous medium, platinum electrode, 298 Kelvin. Understand one thing, beta. Many of the students they tell me after the exam, sir, exam में वही आया जो आपने कराया था, हमने नहीं किया था. So I don't want this to happen with you. Exam में वही आएगा जो मैं करवा रहा हूं. Now it is up to you whether you do it or not. Clear? So we have aqueous medium, platinum electrode, and 298 Kelvin. Clear? So first is we have sodium chloride being electrolyzed. Could you please tell me what would be the product of electrolysis and what will be left in the solution? I'm going to do sodium chloride for you. I will be using sodium chloride for you. And how we do it? I'll make a table, a small table. Here we have the cathode, what is going to be obtained at cathode. And here it is what we are going to obtain at anode. Okay. And here we get what we are going to have in the solution. Is it clear? So, on cathode, it is going to have Na plus and H plus. It's an aqueous medium, so H plus also is going to be there. On anode, we are going to have Cl minus and we are going to have OH minus. Anode is positive, so negative terminal, so negative species are going to move towards it. Now, amongst Na plus and H plus, Na plus is much more active as compared to H plus. So hydrogen is going to be released out. So cathode, we are going to have hydrogen being released out. Am I clear? Among Cl minus and OH minus, that is oxygen and chlorine, I have told you that oxygen has overpotential. So this chlorine is going to be eliminated. So here we are going to get Cl2 on anode. And what is going to remain in the solution? In the solution, we have Na plus and OH minus. So solution is going to have NaOH. Clear? So here, pH increases. More basic it is, higher is the pH. So pH increases. Any doubts? OH कैसे आया अनन्या? It's water. सो जाते हो क्या बीच में अनन्या? Aqueous medium, water, H2O in equilibrium with H plus and OH minus. Clear? Okay then. Any confusions about this one? Sodium hydroxide is being formed in the medium, so it is going to become basic. Okay, now give me the product of the electrolysis if we have copper sulfate. So tell me what we are going to get at cathode, what we are going to get at anode, what will be there in the solution, and whether the pH is going to increase or decrease. So you have to tell me what at cathode, anode, solution, and pH. These are the four things that you need to tell me. Please tell me. Radhika, Radhika. When we talk about anodic discharge series, SO4 2 minus is not released from aqueous dilute solutions. So here we have, don't forget to make the table. This table is extremely important. Don't forget it. Here we have the cathode. Here we have the anode. Here we have the solution. Cathode is going to be Cu2 plus and it's going to be H plus. Anode is going to be SO4 2 minus and OH minus. Clear? Out of the Cu2 plus and H plus, Cu2 plus is going to be released out. So here it's going to be at cathode, copper is going to be deposited. Out of sulfate and OH minus is going to be released out. So oxygen would be released out. And when we talk about the solution, it is going to be H plus and SO4 2 minus, that is H2SO4, which is an acid. So pH decreases. Are we getting it? Okay. Let's have the next one. Copper sulfate. Third one. K2. Nee, K2NO3. Nee. KNO3. Now what are we going to get? Answer. You're not making the table. Ananya, what do we need to repeat? I have told you. Amongst copper and hydrogen, copper is going to be released because copper is much below hydrogen in reactivity series. And sulfate is higher than OH minus, that is oxygen. So oxygen is going to be released out. Hydrogen is not, copper is going to be released out, and we are going to end up with sulfate. Okay. Alapan, did you make the table or you are getting overconfident? It seems to be that you are getting overconfident, Alapan. Here it's going to be, we have again cathode, we have the anode, okay. And cathode we talk about is going to be K plus and it's going to be H plus. Anode it's going to be NO3 minus and OH minus. Out of K plus and H plus goes out. So hydrogen is on the cathode. Out of NO3 minus and OH minus goes out. So it's O2. And the solution is again going to be KNO3. No acidic, no basic, remains the same. Alapan, if you have made the table, what? You have made the table for formality, not for use. Why did you make a mistake? The solution doesn't become acidic. Solution remains neutral. Clear? Okay, let's have the next one. The next one is, let's say we have CuCl2 or CuBr2. Could you tell me what is going to be released at cathode, what's going to be released at anode, and what remains in the solution? Give me the answer. Alapan, don't make a mistake. I am going to make you make a mistake the moment you try to be over smart. No, I won't allow you to be over smart. Give me the answer. आंसर। अनन्या, प्रैक्टिस नहीं करना पड़ेगा, ध्यान देना पड़ेगा। आंसर आपके सामने लिखा हुआ है, आपको सिर्फ एक टेबल देखना है, ये निकलेगा, बात खत्म। व्हाई डू वी नीड अ प्रैक्टिस? आपके सामने पत्थर, मिट्टी, लकड़ी, कांच और सेब रख दिया जाए तो आपको क्या बहुत टाइम लगेगा ये देखने में कि क्या खाओगे, व्हाट यू आर गोइंग टू ईट? बहुत प्रैक्टिस करनी पड़ेगी। यू जस्ट हैव टू अंडरस्टैंड अ टेबल, अ सीरीज. Late Professor BCS Mazental had cup made of silver plated gold. That's it. Yes, Priyanshu. Cathode, it is going to be copper, which is released out. Anode, it is going to be bromine, which is released out, and solution will remain of water. कैसे नहीं बनेगा? इसके तो अंकल जी भी बनेंगे, इसके तो इसके माँ बाप दादा दादी सब बनेंगे. Is this clear? Okay, now let's talk about a very important thing, a concept of reactive electrode. Now, reactive electrode is the one which is consumed during electrolysis. Okay. Most often, it is the anode made of the same metal as cation in solution. Here. And let's have the typical example. Here we have the solution, and here we have a copper rod being made the anode. Here we have the copper rod, again the copper rod only, being made the cathode. And the solution here is of copper sulfate. Now, when the electricity is passed through it, this system undergoes a very peculiar change. Copper ion move from the anode to the solution. So, anode is consumed. Copper ion deposit from the solution onto the cathode, forming copper. Okay. Ananya, I would say that see the session once again, starting part. I believe you were distracted somewhere. Don't be distracted. Okay. Copper is going to deposit on the cathode. So cathode becomes thick. Anode is but consumed, cathode becomes thick. Electrolyte remains unchanged. Clear? Now, if there are any impurities in the anode, they will fall down as anode mud. Okay? Fine. Clear? Okay, so with that, we have talked about the products of electrolysis. And now we talk about Faraday's laws of electrolysis. Faraday's laws of electrolysis. Should we begin over with it? Anything? I believe you are taking the notes. Are you taking the notes? And if you are taking the notes, anything you would like to ask in whatever we had until now? Ask it, anybody, if you want to ask. Anything you want to ask? Okay. So Faraday's law of electrolysis gives a quantitative measurement of electrolysis. They are able to give us how much the species is going to be released out. Now let us say an example. We have Ag plus. To Ag plus, if we add an electron, we are going to get Ag. Okay. So silver plus, when electron is added to it, it's going to give us silver. Cu2 plus, when two electrons are added, give us Cu. Fe3 plus, when three electrons are added, gives us Fe. Yes, you are right, Ananya. Charge of 1 mole of electron is 1 Faraday. But here, we need one electron, here we need two electrons, here we need three electrons for one atom. Okay. Now, if I provided one electron, I get one atom. If I provided two electron, I get two atoms. If I provided three electron, I get three atoms. So as I increase the number of electrons, the number of atoms also increased. Fine. So that simply means that how much species I'm going to get depends on how much electrons or charge I provide. More the charge I provide, more is the species which is being generated. So what I can simply say is the mass of the species generated is going to be proportional to the charge that I pass through it. You may call it small q or capital Q. Now this is what we have as the charge. Now charge is mostly represented as current into time. So M is proportional to IT, that is current into time. Clear? Now this is what we have as first law of electrolysis. Faraday's first law of electrolysis. Clear? Now, there is a definition, equivalent. Equivalent is the amount deposited or released by 1 Faraday of charge. Now, 1 Faraday of charge is 1 mole electrons. That is an equivalent. Fine. And there is something called electrochemical equivalent. Now, that is the amount deposited by 1 coulomb, or you may say 1 unit charge. Okay, that's electrochemical equivalent, 1 coulomb or 1 unit charge. Is this clear? Now to talk about the electrochemical equivalent, it is written as Z. Now Z is equal to equivalent divided by 96500, or you may call it 96487 as per NCERT. Any confusions, any doubts? And is there anybody who has not liked the session as yet? Now that was Faraday's first law of electrolysis. Second law is again very simple. Talking about the second law of electrolysis. The second law of electrolysis. Second law of electrolysis is quite simple one again. It talks about the ratio. If same charge is passed through different electrolytes, then the ratio of masses of different species deposited or released is the same as the ratio of their equivalents. Is that clear? Radhika, the YT classes will continue even after the starting of the plus course. Okay? Clear? The duration might become a little less because at this moment we are finishing off the backlog. So the duration is going to become a little less. But then the classes are going to continue. We are going to finish up the course on YT as well. Okay. Plus course is better, but YT is not bad. Is this clear? We have a class at 8 p.m. special class, so join that special class as well today. Okay? Okay then. So that's what we have as a second law of electrolysis. Second law of electrolysis would mean that M1 is to M2 is to M3 is equal to Z1 is to Z2 is to Z3. That will be equal to EQ1 is to EQ2 is to EQ3. So that is what we have as second law of electrolysis. Anyone has to ask anything here? Till this point, any confusions, anyone? Because now we are going to start with NCERT. Anybody who has to take water, want to drink water, go ahead and drink water and come back quickly. I'm giving you how much? 3 minutes break? Should be enough. We have only 6 students. Ananya, Prerna, Tirthraj, Alapan, जल्दी भागो पानी पी के आ जाओ. Radhika, जल्दी आ जाओ 3 मिनट के अंदर। Back. I have my water along with me. Okay, give me the answer to the first question in text questions. Let's begin with it. We have already done this. N, 2.6. N is 2. It is 2 Fe3 plus. It is 2I minus. So each Fe3 plus undergoes one electron change. So there is a 2 electron change. N की value 2 है. Solve it, solve it. Great. So we have done already done the conductance, and now let's get along with electrolysis. Whatever we have done till now, anything you want to ask? Here is electrolysis. Well, this part, what is going to be deposited? The product of electrolysis is not very much covered in NCERT. So that's what we have done in great detail. Okay. Anybody who has not liked the session, go ahead and like it. Anything you would like to ask? Are we able to understand this part? This is the reactive electrode. This is what we have done. Two copper strips dipping in the aqueous solution of copper sulfate. Read it. This is what we have as the reactive electrode. V4 Bollywood. Wow. Doubt है? What doubt है? You are not a regular student. Doubt क्या है? V4 Bollywood says he has small doubt. So Ananya, I'm not asking about your doubt. Maybe he has seen that. Okay. So here we have Faraday's laws of electrolysis. The first law of electrolysis, just read it. The second law of electrolysis, just read it. And I'm going to shift myself to the side. V4 Bollywood Beta Unacademy Plus subscription has books in it. Uh, Iconic. Iconic subscription has books in it. But I can't say about UPSC CSE subscription. I'm not dealing with it. Okay. I can only answer you the question, the parts which I am dealing with. Okay. Now this is the coulometer. Coulometer, we can talk about the mass. Mass is going to be proportional to the charge. So by finding out the mass, we can find out the charge. Any confusions? Can you solve this question? Read through it and do it in writing. Quick, do it. Solve this particular question. Lapan Mishra, no, don't say it so many times. Let others also do it. There are only 5 students in the class at the moment. So this is the question. Now here it is product of electrolysis. The products of electrolysis depend on the nature of material being electrolyzed and type of electrodes being used. Read through it. Here is the word overpotential as well. What I believe is once you have attended the class, then NCRT reading is going to become very easy for you. Just read through it. Any kind of confusions here? See, we have to do the batteries as well. We are going to do it right now. We are not going to leave anything. I've got only 7 people watching apart from me. Okay, this is written. The reaction at anode with lower value V naught is preferred, and therefore water should get oxidized in preference to Cl minus aqueous. However, on account of overpotential of oxygen, reaction. Is this clear? Any confusions, anybody? Are you reading through it? Now, this is pure physics. But since it has been asked in chemistry, it may be asked in your exam as well. No problem, Steve Raj. Actually, that is because of the font. E naught in old NCRT has written as the V. That is because of the font, writing font. No confusions. When will this class end? If you are not ready to read the NCRT, the class is ended. And if you are reading the NCRT with me, the class is going on. I believe the class is going to end around at 6:30 or 6:45. The only thing which we are left over with is the batteries. Well, I find the batteries to be quite boring because there is nothing to be explained. It is only to be read. Just read it. If you have any kind of confusion, you can simply ask me. Have you read through it? Are you reading it? This is the button cell, which is used in the watches. And the reason is very simple. It has a constant battery throughout its life. And then we are going to meet with the corrosion. Don't worry. What exactly you want to ask in corrosion? Corrosion is also an electrochemical process. Now, Ananya, you are asking me corrosion. Oh, I'm confused in corrosion. Read it. And I assure you, if you have attended the class thoroughly, you will be able to understand corrosion without any problem. Yeah, phone battery is a secondary battery because it can be recharged. Primary batteries can be used only once. Prerna, Intex 3.12. Let me check it out. Intex 3.12. 3.12 or 2.12. Okay, fine. Consider this. The quantity of oxygen columns need to reduce 1 mole of CO2. Yes, you need to multiply simply 96500 by 6. Yes, you are right. It is 6 into 1 Faraday. That is the amount of electricity, or 6 into 96487 coulombs. Yes, you are right. Well, good. You are doing right now. Clear? Now, these are the secondary batteries that can be reused, recharged. Anything to ask here? Yes, Ananya, you are going to get the YT में lecture. जरूर मिल जाएगा, but I'm gonna create another lecture also. That is an old lecture. So I'm going to create the NCRT lectures and upload it on the Unacademy. Okay. So here we have nickel cadmium cells. We have the fuel cells. Fuel cells are quite important as far as the questions are concerned. Read through Ananya, and you will not find any doubt anywhere. Clear? Reading through. Now, this is an important thing. This can be created into a reason assertion question or a simple question. Clear? Okay, now here comes corrosion. Ananya, just read it and tell me if you are able to understand it or now or not. Ananya, you only said that the corrosion was having doubt. So, are you ready to put in the questions? You only have a little time left. So, let's end the chapter and the session. Everybody who has joined the session has liked the session. Is there anybody who has not liked it? So we have the botany at every day 2 p.m. with Swati Batra ma'am. We have zoology with Sachin Kapur sir at 3 p.m. Chemistry with me at 4 p.m. Clear? So that's our daily routine. Join the Telegram channel for YouTube classes PDF. That is t.me/neet elixir. The NEET UG subscription, iconic plus centers. This is what we have as NEET UG subscription. Well, the people who are already in the class, they have liked it, but I only said that is there anybody who has not liked the session? And did you inform your friends? Because still today we don't have many of the students in the class. Are they going to look at it in the later time? Select your goal, download the Unacademy app. You have to be there in today's class at 8 p.m. Don't forget that. Okay? Join with me on unacademy.com/Anoop Vashishtha. This is going to be my page on Unacademy. So go ahead and join it. Use the code AVLive. Subscribe, and that's NEET Elixir by Unacademy for the best live classes. थैंक यू. मिलते हैं आपसे शाम को अब 8 बजे. और अभी आई बिलीव 7 बजे आपकी और कोई क्लास है. They joined and why did they leave? Prerna? They should not have left. Maybe they didn't like the class. This kind of a class is liked by very few people. I can see that. Bye-bye. We are going to meet in the next class. Take care. 8 o'clock. याद रखना.